So hopefully this video works properly and is in sync with each other and everything. I think I've kind of resolved some of the issues with that. Sorry about this video being so delayed getting to y'all. I recorded it the other day and had some technical difficulties, and so it didn't actually save when I recorded it. And so I'm recording it again now for you, so hopefully this section won't be too hard for you and you'll be able to pick it up pretty quickly. So we are in 5.3, which is the sum and difference identities. So we got a lot of identities in 5.1. We use them to prove stuff in 5.2, and now in 5.3 we have a couple more identities. So 5.3, sum and difference identities. Okay, so we have 6 formulas, identities, whatever you want to call them, that we need to jot down. So the formulas, we have 2 for cosine, 2 for sine, and 2 for tangent. Okay, and there's a sum and a difference one. Hopefully you've seen these before, but the cosine of u plus v is equal to the cosine of u, cosine of v, minus sine of u, sine of v. And so that's the sum formula. Difference formula, cosine of u minus v is equal to cosine of u, cosine of v, plus sine of u, sine of v. So notice with these ones, the signs are opposite here, okay, positive and negative. They're opposite. So if you're adding, then you're subtracting here. If you're subtracting, then you're adding here. Okay, so those are cosine. Now sine. The sine of u plus v is equal to the sine of u, cosine of v, plus cosine of u, sine of v. And then sine of u minus v is equal to sine of u, cosine of v, minus cosine of u, sine of v. Okay, so notice these have the same sign. Okay, so sine keeps the same sign. And lastly, tangent. Okay, these two are fractions. So tangent of u plus v is equal to the tangent minus tangent of u, tangent of v. Okay, so on the top it's the same sign, on the bottom it's the opposite sign. Okay, so these ones are a little bit weird. And then for tangent of u minus v, okay, it's tangent of u minus tangent of v, okay, so same sign on top, over 1 plus, opposite sign on the bottom, tangent of u, tangent of v. So there are your 6 formulas that you need. So pretty much everything is just plugging it in. So this is literally just kind of a plug and chug section. Now when we're doing these, we need to know that when we're given an angle and we're finding the sum or the difference of it, okay, u and v need to be known angles. Meaning they need to be on the unit circle. Okay, so for this set of problems, okay, in this type only, okay, so for this problem, or set of problems I should say, to make your life easier, convert radians to degrees. And hopefully you guys remember how to do that. pi over 180 or 180 over pi. Okay, so we need to go through some problems of this type and work through exactly how to do it. Okay, the initial setup, super easy. Most likely, if you have an issue, it's going to come from a mathematical error. Okay, so starting with an easy one. Okay, number 2 from the book says the tangent of 15 degrees. So we need to figure out how to rewrite it in one of these forms up here. Okay, we don't know what the tangent of 15 is, so we have to rewrite it as the sum or difference of two angles that are known in this case. So when I look up here, okay, I can either use the sum or the difference, but I don't know any two angles that I add together to give me 15, so I'm going to need to use two that I can subtract. Now, when you look at this, okay, there's, multiple possibilities here that you can use. Okay, you could use 45 minus 30, you could use 60 minus 45, you could use 135 minus 120. Okay, you get the idea at this point. For the sake of just making my life a little easier, I'm just going to use 45 minus 30. So, it's going to be the tangent of 45 minus 30. And notice I'm not really writing in the degree symbols. Okay, you can if you want to. I'm not going to take off points or anything if you don't. So overall, just write down the numbers. Okay, so 45 and 30, two numbers that we know. So now, just for this first one, okay, 45 is u, 30 is v. So this is equal to the tangent of, okay, we're following the difference formula, so 45 minus the tangent of 30 all over 1 plus the tangent of 45 tangent of 30. Okay, and apparently this marker is dying. Hopefully you can still read that. At the moment, need to switch out and get a different one. So, now I go to the unit circle, okay, and I need to know what the tangent of 45 is. So, the tangent of 45, well, that's easy, that's 1. Tangent of 30 is root 3 over 3, so I'm just going to go ahead and look at both of those while I'm here. So, on the top, I have 1 minus root 3 over 3 all over 1 plus 1 times root 3 over 3. Okay, so on the top I have 1 minus root 3 over 3. On the bottom I have 1 plus root 3 over 3, basically. So 1 minus root 3 over 3 over 1 plus root 3 over 3. And at this point, if we were in class, I would ask you guys how you think we should solve this. So take a second and just think about that. Just think about, if I were to actually be solving this, what would I need to do to get rid of my radicals / the fraction on the bottom? So hopefully you remember that we have things called conjugates, and we need to multiply by the conjugate of the bottom. So I'm going to bring this down here. Okay, so this is equal to 1 minus the square root of 3 over 3, over 3, all over 1 plus the square root of 3 over 3. Now, I need to multiply this by, it's the conjugate of the bottom, which is 1 minus root 3 over 3. Okay, so top and bottom, I'm multiplying by 1 minus root 3 over 3. There. So now, this is equal to, okay, on the top, 1 times 1 is 1. Now I have minus root 3 over 3, minus root 3 over 3. So I have minus 2 root 3 over 3. Sorry, I'm writing kind of small here. That's 2 root 3 over 3 there. Now, I have negative root 3 over 3 times negative root 3 over 3. those radicals are going to end up canceling each other, giving me a 3 on top and a 9 on the bottom, and the signs go away, so plus 3 over 9. All over on the bottom here, I have, this is a difference of squares, so 1 minus 3 over 9. Now at this point, if I wanted to, I could obviously reduce my fraction, but I'm just going to rewrite this as 9 over 9, and I'm going to rewrite this as 9 over 9. So I'm going to get rid of that and rewrite them as 9 over 9. Okay, so now 9 over 9 plus 3 over 9 on top is equal to 12 over 9 minus 2 root 3 over 3. And then on the bottom, 9 over 9 minus 3 over 9 is 6 over 9. So now I can reduce the top. I can take out a 3 from top and bottom, which gives me 4 over 3. So I'm going to rewrite that as 4 over 3. I'm going to rewrite 6 over 9 as 2 over 3. Now, when I divide by a fraction, it's the same thing as multiplying by the reciprocal. So what I can redo is I can come down here and say 4/3 minus 2 root 3 over 3 times the reciprocal, 3 over 2, is equal to, well, because I have a 3 in the bottom of both pieces, okay, I can get rid of the 3 altogether. I have a 4 here, a 2 here, and a 2 here, so what I really have is 4 minus 2 root 3 over 2 is what's left. Okay, just to kind of clean it up a little bit. I can pull a 2 out of both of these things, giving me 2 minus root 3 all over 2. 2's cancel, leaving me with 2 minus the square root of 3. And you might be looking at this point and saying, that's just a lot of algebra stuff that I have to do. It is, okay, and the tangent ones are as hard as they get. Okay, the tangent ones are absolutely the hardest kind of these. Okay, but they're very doable. Okay, it's just following basic rules of math. Okay, and most often your answers are going to look something like this for tangent. Okay, they're going to have something like either 1s, 2s, square root of 3s, square root of 6 is another possibility. Okay, your answers are going to all kind of look similar when you get your final answer. So if your answer doesn't look something kind of like that, I would greatly consider looking and figuring out, you know, hey, did I actually do some algebra right or wrong here? Okay. And obviously, if we have a quiz or test or something on this, you know, if it's your algebra that causes the problem, I'm going to be a lot more lenient with you on that than if you just don't set it up properly or something like that. Okay. So, that's that problem. Let's see. Now, we are going to look at number 4. Get papers fixed here. All right. Number 4 is the cosine of 75. Okay, so the cosine of 75, again, looking at the unit circle, okay, now I could probably do this by finding things that I can subtract, and they'll give me 75, but just at a glance, okay, the easiest thing would be 30 plus 45 to give me 75. So I'm going to do the cosine of 30 plus 45, or 45 plus 30, really, it does not matter which way you do it. So the cosine of 45 plus 30. Now, you just follow the formula that you wrote down earlier. Okay, gives us the cosine of 45 cosine of 30 minus sine of 45 sine of 30. So now looking at these values on your unit circle, okay, I'm not going to throw the unit circle under here. You should know how to look at your unit circle and find those values at this point. Cosine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Minus sine of 45 is also root 2 over 2. Sine of 30 is 1/2. So now I need to multiply these two together. It gives me, and remember when I'm multiplying radicals, I can multiply what's inside. So that gives me that square root of 6 over 2 times 2 is 4, minus square root of 2 over 4, which then just simplifies down to the square root of 6 minus the square root of 2 all over 4. Okay, and I cannot combine the square root of 6 minus the square root of 2. Okay, I'm not allowed to do that. The rules of radicals. Okay, so again, notice I have like the square root of 6, I have the square root of 2, and I have 4, so that's all going to kind of follow that pattern, so I know, okay, my answer looks good. I most likely did not make any mathematical errors. Okay, that's not 100% given, but it's a pretty decent way to look at checking it. Okay, so we need to do another one, but this one we're going to do with radians, okay, or we're going to look at it in terms of radians. So 6 is the sine of 7 pi over 12. Well, I told you that if you have radians, that I would highly recommend converting it to degrees. If you want to see why, go look at examples in your book where they deal with radians and keeping it in radians and dealing with converting your fractions and whatever. It's just easier, trust me, convert it to degrees. So 7 pi over 12 times 180 over pi. And with a calculator, you'd see that that's 105 degrees. So the sine of 105. Well, the sine of 105 is not something that we know on our circle. So again, there are most likely several possibilities that we could use here. I mean, immediately I look at 135 minus 30. I look at 150 minus 45. Okay, so just to name a couple possibilities that you have, I'm just going to go with the 135 and the 30. Not that it really matters, but just the one I'm going to pick. So, the sine of 135 minus 30. So again, just following your formula. This is the sine of 135 cosine of 30. Same sign, so minus cosine of 135 sine of 30. And just reading values off of your unit circle. Sine of 135 is root 2 over 2. Times cosine of 30 is root 3 over 2, minus cosine of 135 is minus root 2 over 2. So make sure you pay attention to those negative signs there. And sine of 30 is 1/2. So over here, I get top square root of 6 over 4. Now, I have minus a negative, so that's going to become a positive. Root 2 on top over 4 on the bottom. So I get root 6 plus root 2 all over 4. So again, that's kind of a common looking answer. So I would say overall, good chance that I'm good, okay, if I was looking at a problem like this. And yes, I have checked them all in the book, so these are the correct answers. Okay. Now, I'm just going to set up number 10 for you because it's a negative one and I want you to see what to do, but literally once I set it up for you, you should be able to do all this stuff down here. So 10 is the sine of minus pi over 12. Now, when you're doing this, okay, don't try to get something and just say, oh, well, a small positive number minus a bigger negative, or minus a bigger number is going to be negative, okay? Convert it, and I'm going to show you what we're going to do. So, minus pi over 12 times 180 over pi gives me minus 15 degrees. Okay, well, minus 15 degrees, if we remember back to the way we can think about angles, okay, I can think of a negative angle as the same thing as that plus 360. So if I add 360, I get 345 degrees. So let's look at our unit circle real quick just to show. So minus 15 degrees would be down here. Well, 345 degrees would also be right here. Okay, so it's the same thing. The negative angle is the same thing as the positive big angle looping all the way around. So if you have a negative angle, once you convert it to degrees, add 360, and you got it. So this is up here, just so we see step by step. This was the sine of negative 15, okay, which is the same thing as the sine of 345. And then the way we could break this up, okay, looking at this, obviously, again, multiple options, but an easy option that I just see right off the bat is 345, and I could add those two. So this would be the same thing as the sine of 300 plus 45. Okay, and then you guys should be able to just follow the formula down and do that. So I'm not going to do another one. Now, the next type that we have is kind of the reverse of this. So with this one, we have, so the stuff like, let's see, where does this start? 11 through 22, it looks like, kind of follows this pattern here. So this was, we're given cosine of 94, cosine of 18, plus the sine of 94, sine of 18. So we want to get back to what the original problem statement was. So in this one, they've already filled in the formula. We want to tell what it was the sum and difference of. Okay, so it's kind of the reverse of what we were doing up here. So, based on looking at my formula sheet, okay, I have cosines all listed first. I have sines all listed second. So that tells me that I'm dealing with a cosine. I know with cosine, this positive negative here is opposite of whatever I'm dealing with. So I'm dealing with cosine of, or the difference formula for cosine, the difference formula for cosine, okay? So I know that I have the cosine of something minus something, okay? And I know it's u minus v then, so 94 minus 18, which is equal to the cosine of 94 minus 18 is 76. So the cosine of 76 is the answer for that one. Okay, so these are probably almost easier actually than the other ones. All right, let's see. Let's look at 14, I guess. So 14, we have the sine of pi over 3 cosine of pi over 7 minus the sine of pi over 7 cosine of pi over 3. Okay? So with these ones, leave in radians. Okay, with this type, leave in radians, get a common denominator. So, I have a sine cosine minus a sine cosine. So looking at my formulas, I know that means that I'm dealing with sine. I know with sine, we keep the same positive negative sign between. So I know that I'm dealing with the sine of something minus something. So the sine of, in this case, okay, it's going to be pi over 3 minus the pi over 7. And now to get a common denominator, okay, the easiest thing I see is just to multiply this one by 7 over 7, which gives me the sine of 7 pi over 21 minus, multiply this one by 3 over 3, and that gives me 3 pi over 21, which gives me the sine of 7 pi minus 3 pi is 4 pi over 21. So the sine of 4 pi over 21, right there, and that's the answer for that one. Okay, so just a couple more things here. Get a new piece of paper. Let's see, we're going to do 16 now, so we see a tangent one. See what that looks like. So again, these are a lot easier with this type, in my opinion, than the other way. You're not actually trying to solve these huge, fractions like we did in that first example. So we have the tangent of pi over 5 minus the tangent of pi over 3 all over 1 plus the tangent of pi over 5 times the tangent of pi over 3. Well, I know that with tangent, okay, looking at the formulas, the top sign is the same sign as what I'm dealing with. So I'm dealing with the difference formula for tangent. So this would give me the tangent of pi over 5 minus pi over 3. So multiply this one. You got to get that common denominator. So multiply this one by 3 over 3. Gives me the tangent of 3 pi over 15 minus this one is going to give me, if I multiply by 5 over 5, minus 5 pi over 15, which gives me the tangent of negative 2 pi over 15. And with these ones, it is okay to leave them as a negative. Okay, so that's that type of problem there. So one more problem that you're going to be responsible for is a problem like 48. Okay, so with 48, it says to prove the identity. Okay, so we're proving the identity, meaning we're dealing with one side of the equation. Okay, so prove the identity. Okay, so the cosine of x minus y plus the cosine of x plus y is equal to 2 cosine of x cosine of y. Okay, so I can only deal with the left-hand side here. Okay, so I can only change the left-hand side, or I can only work on the left-hand side. So I'm going to rewrite this. The cosine of x minus y is, according to the formula, cosine x, cosine y, opposite sign, so plus sine of x, sine of y, plus, now if this was a negative, I would have to put this all in a bracket, so I would pay attention to the negative sign, but it's positive, so I don't have to worry about it. Now, cosine of x plus y is cosine of x, cosine of y, opposite sign, minus sine x, sine y, is all equal to, and I can just draw an arrow to bring that stuff down. Well, sine of x, sine of y, positive, and then it negative, those cancel, those go away, leaving me with 2 cosine x, cosine y, which is equal to 2 cosine x, cosine y that I started with, and I've shown that that is true. Okay? So, your homework for this section is 1 through 21 odd and 47. So 47 is basically just like 48. Okay, that's as hard as we're going to go with those kind of proving these ones. Just a reminder, if you have any questions, get those questions to me. Easiest way is with that Google phone number I gave you. And don't forget, your homework is due Sunday night, not tomorrow when you guys come in.